All right, part A. Where is f increasing? So generally I'm thinking where is the derivative positive? Where's the slope positive? So let's see, if I have f of x, I'll just use my rules and find the derivative. And then I'll find where it's 0. And then I'll do a little sign chart or something. Or if I'm not multiplying and dividing by a negative, maybe I could just solve it. And I'll find where f is positive. 2x e to the negative x, it's two different functions, so product rule and factor. Little tricky on the factoring, but the product rule nice and easy, I hope, at this point. And so, yeah, it doesn't actually say to justify, but I would probably write out right away f of x is increasing on because f prime of x is positive on that interval. Okay, letter B, at x equals 1, f prime is 0. We just did that. Oh man, we should have looked at B first. Does f have a min, max, or neither? Oh, so we just say f has a max because the derivative changes from positive to negative at 1, or min because the opposite, or neither because the derivative. So we just need to make a sign chart, which we probably already did for part A. So I'll actually write that out real quick. So I just plugged in, showed that 1 is 0, and then I plugged in 0, got negative, negative, plugged in negative 2, negative, positive, negative. So since f prime changes from positive to negative at 1, there's a max at 1. Huzzah. Is there a point of inflection? So now I need to see second derivative and plug in 2 and do two things, right? Is it 0 there? Is the second derivative 0? And does the second derivative change sign? And so we go back and we look at second derivative. So we just do product rule and then just a basic one. So here's product rule. They went, in the answer key, they went from the already factored form. So just did product rule here. You could have also gone, I probably would have gone up here, done a product, and then tacked on this. A little bit tricky on the, again, factoring out this at the end so that I could then combine the negative 2. Oh, they took out the negative 2 also. Oh, no, they took out a 2 also. So this only left with the negative 1 here. And then they took this out, so they're left with x minus 1, which then all became that. And so, yes, when I plug in 2, I get a 0. And it changes sign there. Now, they didn't actually show that, so again, probably should make the SIGN chart, which could just be added to our other chart up here. I could just add on an f double prime of x. At 2, I have 0, and at 3, I have down here, plug in 3, I get a positive and a positive. And plug in something like 0. 0, I get a positive, negative. At 0, so I get a negative. And so the second derivative changes sign. There's my actual work for that now in green. Are there any horizontal asymptotes of f? Something does f prime ever equal oh no, horizontal asymptotes. Oh wow, I was thinking horizontal tangent lines. F prime is 0. We already did that. No, horizontal asymptotes just means what happens is you plug in infinity or negative infinity. Do you ever get a number? And they could have, a function could have 0, 1, or 2 horizontal asymptotes. They don't have to match on the left and right. There probably is because e to the negative x has an asymptote at 0. And so this function probably does. And so we just need to take the infinite limits on both sides. And so they went ahead and showed that work here. The limit as I go to negative infinity is still negative infinity. Both sides use this. I'm just rewriting the original function with the e to the x on bottom gives you this function. If you plug in a negative infinity to here, you get negative infinity. If you plug in a negative infinity here, e to the negative infinity is e. You get infinity times infinity, that's infinity. Except it's negative infinity because 2 times negative infinity is negative. Sorry. So that one, yeah, so that's not an asymptote. And I think you have to show that for full credit that you at least tested that side. Now on the left, or the other side on the right, now you have infinity times 0. Infinity times 0 is indeterminate, but we want to rewrite it as preferably infinity over infinity or 0 over 0. And so now we can rewrite it like this, and now we have infinity over infinity. Here's how you show it by L'Hopital's rule, is you say, since the limit of this is infinity and the limit of this is infinity, L'Hopital's rule applies, and then you'd simply take the derivative of this, 2, derivative of this, e to the x, and now if I plug in infinity, I get nothing over 0, or sorry, over infinity, which is 0, therefore an asymptote at 0.